In lesson 2.3b, we're going to talk about what's called the remainder and factor theorems. And it has to do with inputting values into a function and getting the output, and then how synthetic division relates to that. What it basically says is, so I'm given a polynomial, some function, and I'm going to divide it by x minus c. Okay, and we found that in synthetic division, we actually solved, and we would actually divide by the c here. What the remainder theorem tells me is that if I put c into the function, so if I input it into the function, then my output is actually my remainder. So if, for instance, if I would get a output when I put c into the function, whatever c is, and I get an output that's 0, that would mean that my divisor is a factor of the polynomial because I have no remainder. If I get something other than 0, then that tells me that my divisor is not a factor. So we're going to try it out. And the first example is a little bit more involved, I guess. We've got a function here, and it says the number of tickets sold during the North Side high school football season can be modeled by the given function. So T is the tickets sold, and X is going to be the number of games that the team has played. It says use the remainder theorem to find the number of tickets sold during the 12th game of the North Side high school football season. Well, if I use the 12th game, that's going to be, if I put 12 into the function, that's actually going to give me like how many tickets were sold from game 1 all the way up to game 12. So I'll back that up a little bit. It's not 548. Don't even know if I can back it up. Well, we'll just mark it out. So it's not 548. Sorry about that. It is 576. And then when I add those numbers together, I'm going to get 650. That's actually my remainder. That is how many tickets I've sold through the 12th game. Then I'm going to do the same thing with 11. So I still have the same coefficients, negative 1, negative 12, 48, and 74. And this time I'm going to divide by 11. So we want to bring down the 1. 1 and 11 is 11. The sum is negative 1. 11 times negative 1 is negative 11. When I add those, I get 37. And 11 times 37 is 207. Sorry, 407, not 207. Okay, so I'm going to add those columns, and I get 481. Okay, that's my remainder for 11, which is the output that I would get if I put 11 into the function. So to find the number of tickets, I'm going to take that 650, which was T of 12, minus 481, which is T of 11, and the difference is going to be my answer. Which I should get 200 and just kidding, 100 and 169 tickets. Okay, the factor theorem just tells me if I have a factor. The factor theorem tells me whether I have a factor or not. If I get a factor or a remainder of 0, then my binomial that I'm dividing by is a factor. And if I get something other than 0, then I know it's not a factor. So I'm going to take my coefficients. I have 4, 21, 25, -5, and 3. And I have x minus 1, so when I solve for x, I get a 1, and that's what I'm going to divide with for my synthetic division. I'm going to bring down the 4. 1 times 4 is 4, and then you add the columns, so that's 25. 1 times 25 is 25, and then I'm going to add that column, I get 50. 1 times 50 is 50, and then I add that column, I get 45, and 48. That's my remainder. What that tells me is that x minus 1 is not a factor of the polynomial because I have a remainder of something other than 0. So I'm going to try for the second one with x plus 3. Still do the same thing, write down your coefficients. When I solve for x with x plus 3 equals 0, I get -3 this time. You want to bring down your 4. I'm going to multiply the -3 times 4, which is -12. And when you add those together, you get 9. -3 and 9 is -27. Add those for -2. -3 and -2 is 6. That sum is 1, and -3 and 3 is -3. And that gives me a sum of 0. So that tells me that x plus 3 is actually a factor. I'm going to leave the next example for you to work out. You also have page 115, numbers 30 through 46, the evens, to do on that one.